What do you got for me?
Good morning, folks.
Are you cool?
Hey, everybody. It's your heads up.
'Cause I'm gonna be dropping some hard Thor news science upon you. Stay cool. Hit the button, baby.
Well, this is space. There's space all over the place.
Hell yeah! We're flying now! And this is a Thor News presentation. Thor News presents Party Dance Time. Well, this is fascinating. I'm over here at Centauri Dreams, imagining and planning interstellar exploration. Though right now it's like 99.9% imagining, and the rest is all robot interstellar exploration, which I'm not too excited about, but that is neither here nor there. I'm talking about planet in widest orbit yet discovered. This is by Paul Gilster on January 26th, 2016. You see, free-floating planets without any star, are exotic things, presumably thrown out of their original solar system by gravitational interactions with other worlds. Yeah, or if planets are like siblings, they fight all the time for supremacy, to get the most love and adoration by their home star. But the line between such wanderers and bound planets isn't always clear. A case in point is the object 2-mass J2126, found in an infrared sky survey, and at one point considered to be part of a group of young stars known as the Toucan Sam Horologium Association. If linked to this group, its age could be inferred, and it was young and low enough in mass to be considered an independent planet. Say what? Yeah, there is a really weird difference between planets and stars and failed stars, brown dwarfs, and whatnot. I would say we don't know much, and I would say planets could be stars and stars could be planets eventually in a long enough timeline. Nobody knows, man. We're human beings. We live about 100 years. Stars supposedly live billions of years, so how much can we really know? You know? That's what I'm talking about. Now we learn otherwise. As a research team from the United Kingdom, Australia, and the United States have determined that 2-mass J2126 is in an extraordinarily wide orbit around the star TYC Tender Yams Care 9486927-1. Lead author Niall Diacon, University of Hertfordshire, has been focusing for several years on young stars with planetary companions in wide orbits. That sounds kind of nasty. Is that legal? But this star system has to come as a surprise. The young planet is about 1 trillion kilometers from the star. Wow, that's far. A whopping 7,000 astronomical units. Well, it sounds like Planet X's come in all size, shapes, and variety. And it makes you wonder about how far does the star's empire go? I mean, can it hold a planet or a star 7,000 AUs away? You know? I don't know. Do you? By way of comparison, 2,000 to 20,000 AU is thought to be the extent of the inner Oort cloud. Wow. Also called the Hills cloud. Wait, who calls it that in our system? And I've seen the numbers on the inner and outer Oort cloud vary widely, greatly. You know, the Oort cloud itself is a theory. It's not like anybody's explored it. It's not like we've taken a picture of it. It's just an idea. Proxima Centauri is roughly 15,000 AU from Centauri A and B, which are stars also. I think little more than twice the distance of 2-mass J2126 from its star. In this work, we present the identification of 2 previously known young objects in the solar neighborhood TYC 9486-9217 and JMass2 as a co-moving wide pair binary with a probable planetary mass secondary. During an examination of the literature, we found that these 2 objects are separated by 217 quotation marks. What does that even mean? 217 quotation marks? That dude be talking a lot and have similar proper motions. Hence, we attempted to better determine their properties to see if they were a likely young bound system. Using revised astrometry and detailed kinematic analysis of nearby young stars and brown dwarfs. How nearby, bro? We have determined that this previously known young brown dwarf, free-floating planetary mass object, and young low-mass star are a likely widely separated bound pair. They are very far away, going in the same direction. Maybe those stars just have similar ways of thinking. You see, false color infrared image of TYC and 2-mass J2126. The arrows show the projected movement of the star and planet on the sky over 1,000 years. The scale indicates a distance of 4,000 astronomical units, where 1 AU is the average distance between the Earth and the Sun. This article's kind of boring. That's it. Like, it's really far away and they don't know. Planets in very wide orbits are scarce. A currently small but previously unexpected population of massive gas giant companions to stars. But we do have 4 others. WDOI-06 2500 AU, GUPSB 2000 AU, SR12C 1100 AU, and Ross and Rachel 1060 AU. All 4 of these objects were discovered through direct imaging, just over 100 light years from Earth. 2-mass J2126 126 can now lay claim to the widest orbit of any planet found around any other star, with each revolution taking some 900,000 years to complete. Wow, so one day on that planet is 900,000 years? So if you live to be 100 years old, that would mean you're really old, you know what I'm saying? This is the widest planet system found so far, and both the members of it have been known for 8 years. But nobody had made the link between the objects before. The planet is not quite as lonely as we first thought. Sea planets do have emotions, but it's certainly in a very long-distance relationship. Good joke there, buddy. I love astronomer jokes. They're hilarious. You see, what they did is they studied the spectroscopy and found that the stars had similar signatures. So obviously they had to be from the same place, same solar system, I'm guessing. I'm paraphrasing it a bit because, I don't know, Tuckhor, it's a weird word. As mentioned above, the earlier presumed connection with the Tuscan-Sam Horologium Association offered a way of establishing the age of its star. Scientists are so good at stellar dating. Dating humans, not so much. But without being able to confirm that connection, Deacon and team studied the parent star spectrum, finding that TUIC 9486 shows a stronger signature for lithium than will be expected in a 45-million-year-old stars. I don't know why that sounds stupid. Maybe I'm just stupid. Who knows? Maybe we're both stupid. Lithium is destroyed early in a star's life. Always, across all stars, dude? You really know that, you think? So the lithium signature can be a valuable marker. And when was the last time we saw a star born? Huh? Can I pretty please see a complete progression of the main sequence of star birth to death put together from a bunch of photographs that you guys have? No? Okay. The star's lithium signature is also weaker than 10-million-year-old stars, making the probable age somewhere between the two figures. The paper compares the star to different stellar moving groups, remnants of a stellar association still moving roughly together. It is clear the TUIC 94869271 has stronger lithium absorption than stars of similar spectral type, and Tuckhor weaker absorption than TWA Hydrae members, but in reasonable agreement with Beta Pictoris members. We love Beta Pictoris. Based on this comparison, we conclude that TYC 94869271 is older than TWA and likely of similar age or younger than Tuckhor. Thus, our lie analysis, our lie analysis. Can you read between the lines there? Suggest an age comparable to the Beta Pictoris moving group. But we note that the lie depletion, in low-mass stars can be affected by initial conditions, rotation, episodic accretion, and we therefore adopt a conservative age range of 10 to 45 million years. Yeah, that's really conservative, man. With these age estimates in mind, the team went on to estimate the mass of the planet. Of course they did, which turns out to be the boundary between the planets and the brown dwarfs. 11.6 to 15 times the mass of Jupiter. The closest analog we have to 2-mass J2126 then is the planet Beta Pictoris b, although the former is more than 700 times further from its host star. How a planet in such a wide orbit forms in such a system would be interesting fodder for future work. You're telling me? I think the farthest planetoid we have is Sedna at 10,000 years, like 82 AU. So the solar system still is magical, mysterious, and we don't really know much about it. Yay! Don't these planets have implications for the current Planet 9 hypothesis? It seems that the existence of large planets in distant orbit is relatively common. The hypothetical Planet 9 would not be an oddity at all. Are there any crude statistics that can be inferred? What is the likelihood of a star having a 1000 AU Neptune size or larger companion? Why can we see this one and not Planet X? Bum bum bum. We've seen the 9th planet, but haven't noticed it. Oh really? Perhaps it's sitting around in the WISE catalog somewhere, waiting to be noticed. Bum bum bum. Or maybe there's just no additional planet in the solar system. Because to do that, you would have to clear your orbit to be a planet. Phil says, because this thing is massive and young, thus self-luminous. That sounds like Phil played. 6,000 AU is 1 light month, 60,000 AU is 1 light year. That's interesting. See, we learned something. The story may have been boring, but we did learn something. Excellent. I'm sorry that I made a boring video, guys. Please forgive me. I'll try not to make that mistake in the future. Peace out. God bless everyone.
No, I don't wanna be misunderstood. I hope you haters know, most importantly.